This study is about the evaluation of SST from different reanalysis products in the northern Indian Ocean region. Ocean reanalysis are valuable tools to study the historical and present state of ocean. SST is a key factor that helps us understand the air-sea interaction. Ocean reanalysis products suffer from errors due to model physics used, assimilation methods, forcings, etc. So, it is necessary to validate the reanalysis products with independent observations. Here, in the study, we have used 11 reanalysis products at 12 omni-mode buoy locations. We have compared the SST from the buoys with the reanalysis SST, and then the spatial pattern of SST from the reanalysis is compared with satellite derived SST products such as AMSR2, OISST and HAD-ISST. The table here shows the different reanalysis products used in this study with its details. This figure shows the location of omni buoys used for this study. Moving on to the result and discussion part, we first evaluated the temporal change in SST at each of the buoy locations and the distribution of temperature there. This figure shows 4 representative buoy location time series as well as its corresponding histograms. These buoy locations were chosen such that 2 of it represents the Arabian Sea and 2 from Bay of Bengal. So one is from Northern Arabian Sea, one is from Southeastern Arabian Sea, and the other is from Northern Bay of Bengal, and the last one is near Andaman Nicobar Islands. It was observed from the time series that maximum biases were mostly seen during the spring as well as winter seasons. And in the Arabian Sea, reanalysis products shows more cooling in winter, but in the Bay of Bengal, the cooling is comparatively lesser than that of observation. Overall performance of the reanalysis SST was then carried out by averaging the SST from all the buoy locations. It is seen that there is a tendency for the reanalysis products to underestimate the observed value. However, ECHO shows warmer bias throughout. This is probably because of its higher SST simulation in the Bay of Bengal. In this time series, we can see that BRAN and NEMO-based reanalysis products underestimates the SST during fall. The second figure here shows the mean averaged temperature of reanalysis products and buoy observations at each buoy locations. Here we can see that the reanalysis products underestimate the observed buoy SST slightly at every location. The correlation and RMS spread of different reanalysis products are shown in this box plot. All the reanalysis products show correlation higher than 0.95, with most of the value in the range above 0.97. GREB and GODA's for P1 stand on top of the list with a correlation higher than 0.99. In the case of RMSE, ECHO shows the highest spread and the GODA's for P1 shows the lesser value with least spread. This figure shows the correlation and RMSE for all reanalysis products corresponding to each location. The heat map of correlation shows that reanalysis products perform better in the open oceans. Hence, all the products show a higher correlation at AD06, whereas it is least near the coast, as represented by PD12 here. In the figure, the best performing product at each location of buoy is marked with black in the case of correlation and RMSE separately. GREB shows the highest correlation in most of the locations, and SODA shows the least RMSE. After the comparison with buoy observations, the reanalysis SST is then compared with satellite derived SSTs of AMSR2, MoES and SST. The mean SST pattern show that all the reanalysis products underestimate the AMSR2 mean value. It is interesting to note that the MoES-based reanalysis products show a warm pool to the west of 90 East Ridge and the Lakshadweep Ridge, but in other products the warming is continuous throughout the equatorial Indian Ocean. ECHO here shows a considerable warm bias in the Bay of Bengal and a cooler bias in the Arabian Sea. Similar to the mean SST, the standard deviation of the SST is also underestimated by the reanalysis products with respect to AMSR2. The INCOIS chorus captures the spatial mean SST pattern more closer to the AMSR2 SST during the winter season. In conclusion, we can say that the SST from the reanalysis products is better performing in the open oceans, whereas it is poorer near the coast and islands. The winter cooling is captured differently in Arabian Sea as well as Bay of Bengal. In the Arabian Sea, the winter cooling is more compared to the observation, whereas it is lesser than that of observation in Bay of Bengal. At every buoy location, the ensemble averaged SST of reanalysis products is lesser than that of the mean observed value. While looking at the spatial pattern, the reanalysis products tend to underestimate the observed mean and standard deviation in comparison with AMSR2 data. It was also observed that the warm pool to the west of 90 East Ridge and Lakshadweep Ridge systems in the equatorial region is captured only in MoES-based models, whereas the warming is continuous across the equator in other reanalysis products.